Hello, so today we're going to talk about Unit 2.3, which is plotting points, graphing lines, and applications of such things. To start off, I want to just give a short outline of the rest of the semester. As you know, after this week, we have 2 more weeks. This week, we had a test for the first portion of the week, Monday and Tuesday, and now we're covering section 2.3. Next week, we're going to talk about section 2.5, and then I'll also give you the ability to do an optional lab. And why I call it optional is you don't have to turn it in if you don't want to. It'll be related to section 2.3, what we're doing today. And the lab will replace your lowest lab grade. So if you have a lab grade that's kind of low and it's bringing your lab average down, you can take this optional lab grade, and if you do well on it, replace that grade. Okay, and then we'll also prep for the final next week just a little bit. I'll give you a study guide to help you prepare. And then for the final week, we'll meet on the Tuesday, and we'll just go over some questions that are similar to the final exam. I'll answer any questions you have regarding the final exam. And then Thursday and Friday, you have the ability to take your test. The final exam is either on Thursday or Friday, whichever day is better for you. So if you have questions, feel free to send me an email. I'll look at them and let you know, like if you have questions about the final exam or anything we're covering today in class, just send me an email. So what I want to start with is the Cartesian coordinate system. Now, some people call this the XY plane, and some people call it the rectangular coordinate system. And I think that's what your book calls it, the rectangular coordinate system. But the idea is you're going to make 2 number lines, and you're going to make them perpendicular. This horizontal line right here is called the x-axis. I'm going to try to zoom in just a little bit. And this vertical line is called the y-axis. Now the center is called the origin. And these are number lines. So the center of a number line is going to be 0. And then if you go to the right, I'm going to make these tick marks. I'm going to try to evenly space them. I'm going to let each one of these tick marks be a unit. And this arrow means it goes on forever. So if you move to the right of the origin, the numbers increase. And if you move to the left, we're going to write negative numbers. I think I made these a little bit closer than over here. That's okay. The idea is the same though. The further you move away, the bigger the absolute value of these numbers gets. And then the y-axis is similar. In fact, the y-axis is just taking this number line and rotating it 90 degrees counterclockwise. So this is 1, 2, 3, 4, 5, and so on. And down here is like this piece of the number line. It'll be pointing downward. So you have -1, -2, -3, and so on. Now you don't have to memorize this or anything, but you can see that the graph is broken into basically 4 areas. This area right here, this is an area, this is an area, and this is an area. Each of these areas are called quadrants. This is quadrant 1. This is quadrant 2. This is quadrant 3, and this is quadrant 4. So they're labeled in a counterclockwise fashion. Okay, so the next thing we're going to talk about is plotting points. We'll be given an x value and a y value. So let's say x is 2 and y is 3. We can write this as a point where the x value, it always comes first. So this is going to be 2, 3. And what we're going to do, if we want to plot the point 2, 3, we say, okay, this is the x value, and I'm going to find 2 on my x-axis, which is right here, okay? I'm just going to make a little dotted line. And then I'm going to look for 3 on the y-axis. So the y-axis is the up and down axis, and 3 is right here. And where they cross, that's the location of this point, 2, 3. Let's try another one. Let's go with the number or the point -4, 1. Let's see if we can plot that real quick. So -4 is the x, so we find -4. There it is. And then we find, now if you need to, you can make a dotted line. When you get used to this, you won't have to do that so much. And then you find 1. And where these two cross, that's the point -4, 1. Now what I'm going to do is I actually have sort of like some graph paper on the next couple of slides, just so I can have these tick marks evenly spaced. And when you do this, you can do it on your on a piece of paper, just kind of sketch it, get an idea. And I'll also show you how to use Desmos to plot points in just a few minutes. So let's look at the next slide. Here I just want to plot a few points, and I actually copied Desmos. I took a picture. If you remember from desmos.com, there's a graph that's on the right side. And that graph is a plane, and we can graph points using that plane. So I just took a picture of that so I could have a nice graph. And what I'm going to do is I'm going to plot these points. Now I encourage you to, as I do these points, after a couple of them, maybe pause the video and see if you can plot the point on a sheet of paper. And then check to see if you get the same answer I get. So let's start with A. I think I already did this one. So A is 3, 2. So here, these tick marks are units of 1. So 1, 2, 3, up 2. This is the point A. And I'm going to label them like this because I'm going to have several points, and I want to make sure that I know what point goes with what letter. Let's go with B. So the x is 6. Okay, here's 6. And the y is 0. And that means we don't go up or down because 0 is right here. So this is point B. I think I'm limited on the number of colors, so I'm going to have to go between black and red here. But if you have colored pencils, it's great to label these different points with different colors. So let's do C next. 1, -5. So x is 1, which is right here. And then I go down to -5. So that's point C. Then for D, sometimes I get B and D confused. Even after doing it for so many years, I still get the 0 part confused. But this is 0, and that's in the X. So here's 0, and then we're going to go down 7. So you're not going this way. That's what I happen to do sometimes. I don't know why, but it only happens when I deal with the 0. But this is point D, because 0 for X means I don't go left or right on the number line, and -7 for Y. For E, -5, 5. For F, -8, okay, I think that's right here, 6, 7, 8, and then -9. This right here is -9. So that's F. And then finally, G is 0, 0. That means I don't go left or right, and I don't go up or down. I am right in the middle here, and that's the origin. You can think of the origin as where everything starts, right? So in the center, if you go further away from the origin, the numbers get bigger. So this is the origin, which is G. I hope that makes sense in how we graphed everything. I think the important thing is to keep the X's and the Y's straight. You have to remember that X comes first. If you don't remember that, the points will be in the wrong location. So if you assume, for example, this is Y, then you'll be at 3, 2, which would be 2 up 3 right here, and that's incorrect. So be careful with that. Okay, so let's talk about graphing lines. The first thing we're going to do is just draw a basic line. I'm going to give you 2 points. All you need to draw a line is 2 points. And we're just going to draw a straight line through it. So here's a point, 2, 3. So let's find it. 2, 3, right here. And I'm going to put 2, 3 like that. And then -5, -4. Okay, and now we're going to draw a line through it. Now, if you have a ruler or something on a sheet of paper, I would use that and just draw a straight line right through those 2 points. I kind of have trouble because I have to look at a screen and I'm writing with a tablet, and it's really hard for me to make a proper straight line. So if I don't do it the first time, forgive me. Sometimes I make a dotted line. That helps. See, like I'm already can't draw a straight line here. So I might just make a dotted line. So oops, there. I think that's pretty good. I don't think that's too bad. And now I'm going to continue this line up like it's almost straight. So the line looks something like that. Let's try another one. And before we move to the next one, what do we notice about this line? It's going up and to the right. In a few minutes, we'll talk about slope. And slope is, you can think of it as an incline or a decline, like if you're driving in a car and you're going up a ramp, you'll think of slope as the steepness of the ramp. And so for our particular example, this line is like going up. If you were a car on this line, let's say right here, you're kind of going up. So this is going to have a positive slope. But if you're going down, we think of that as a negative slope because it's a decline. So let's try to draw another line through the points -5, 2 and -3, -4. So here is the point -5, 2. And then -3, it's right here, and then down 4. I like to label them. You don't have to do that if you can see what they are. Again, I'm going to do my best to draw a straight line here. So it looks something like that. And so definitely this line, as you look from left to right, it's going down, right? So it's going down and to the right. So this would be like a decline. So that brings me to my next topic, the slope of a line. So the slope is going to measure that steepness. So it's a measure of the steepness of a line. Now I'm going to draw 3 examples of, well, actually, I think I'm going to do a few examples, more than 3, maybe like 7 or 8 examples of just a car going up a ramp, okay? So I'm going to have different ramps. So here's our first ramp. Maybe this one's the second ramp. And then let's say this is the third ramp. And then let's also do a decline. I'm going to try to make these as straight as possible. Let's also draw just a straight road. And then let's draw something strange. I'm going to do that. Excuse me. Okay, so I'm going to have a car on each one of these. And we're always going from left to right when we're driving cars on ramps, okay? And that's what we're going to assume anyway. And these are my impressions of little cars. Okay. So let's look at the first 3 here. Which one of these 3 ramps is the steepest? Which one is the least steep? And which one is somewhere in the middle? Think about that for a second. Maybe write 1, 2, and 3, where 1 is the steepest, 2 is the middle one, and 3 is the least steep. Okay, so this one is the steepest, right? Think about your car. You'd really have to force that car to go up that hill. This one is in the middle. And this one is the least steep. It's just a little incline. So when we talk about slope, we're going to actually measure it, and we're going to give a number for that measure. That number is going to be a whole number, or it could be a fraction, something like that. But the bigger the number, the more steep the line will be. So what we're going to think of is this piece of the ramp is like a line. And as long as that line is going from left to right, is kind of going up, then you're going to have a positive value for your slope. So the bigger the number, the more steep. So I'm just going to give an example. Right now, we don't have the tools to measure the steepness of these particular lines or ramps, but we're going to come up with numbers just to have an idea, because the steeper it is, we can say the steepness is 5, for example. Well, if this one's in the middle, maybe it's something like a 3. And this least steep, maybe it's a 1. So the bigger the number, the more steep that line is. Now we can also talk about cars going down a hill. And you could think of steepness too, like right here, this car would really have to hit on the brakes to go down that hill because it's really steep. However, it's steep in a downward direction. And how we can tell the difference between upward and downward is if we put a positive or a negative with it. So this would be the steepest. This would be in the middle. And this would be the least steep. So this could have a steepness of a -5. And the negative tells us that we're going down. If it's a +5, it means we're going up. And so we have, as you can see, like a line right here. And here's a line too. And then here's a line. Okay, so this one would be like a -3, and this one would be like a -1. Similar to the idea over here, where the 1, 3, and 5, that kind of gives us an idea of the steepness, and the negative tells us if we're going down or And if it's positive, we're going up. Now, what happens if we don't have any up or down? We're just going down a straight road. Well, then the steepness would be 0. That's going to be the slope here. So whenever we have a horizontal line, the steepness is 0. Finally, let's say I ask you to go up this straight line, this vertical line. It's like impossible, right? If you're on a car, how can you go climb a wall, right? And how do you measure the slope of something that's completely vertical? Well, it turns out for something that's vertical, the slope is undefined. You could think of it as like infinity, because the bigger the number, the more steep it is. And the number can keep getting bigger and bigger, which tells us that we can keep getting steeper and steeper. But once you're past going straight up, then it's like you're kind of going downward. So that's like, you could think of it as infinity, but we're going to say it's undefined. For something like a test, I would ask you, well, you would have to measure slope, but I also want to make sure you understand this concept of what slope is. It measures the steepness. So positive means we're going up and negative means we're going down. If it's 0, we're just straight. And if it's undefined, we're going straight up. Okay, so let's do the next concept is the y-intercept. Now, suppose we have the xy plane and we graph some kind of line. Let's say this is the line. Where we cross right here on the y-axis, that's called the y-intercept. Do that in a different color. So the y-intercept is where we cross the y-axis. You see, here's the y-axis where we touch it right here. So what is the value of the x for this point? Remember, this is the x-axis, and this is 1, 2, 3, 4, 5, -1, -2. The x value is 0. So this point is always going to be 0, something. And usually the letter that we use to represent the y-intercept is the letter B. So it's some number here, B. It could be 7, 4, something. I'm just going to say it's some number. B is some number. But this value is always going to be 0. And that's the y-intercept. We can talk about an x-intercept too. That's not necessary right now, but this is the x-intercept. And that's where we cross the x-axis. Okay, so the x-axis, this point that's on this x-axis will always take the form a, 0. And that's because the y value, you're not moving up or down past that x-axis, right? If we try to figure out the y value. So definitely for your homework, you're going to have to know what a y-intercept is, but it's good to also understand what an x-intercept is. All right. Remember, at any time, you can pause the video, you can, I guess, rewind it a little bit and look at something if I went too fast or you need some more time to write stuff down. Before we talk about the slope-intercept form of a line, I want to look at a few examples. So I'm going to come right back to this one. But what I want to do is I'm going to go back to where we were talking about the slope of a line. I'm going to clear this. And what I'm going to do is I'm just going to give you an example. And then we'll talk about the slope-intercept form. So let me erase, oops. Just a second here. So what I'm going to do is I'm going to draw a line and we're going to figure out that slope. In fact, maybe it would be better. Here, I'm going to do it right here. I'm going to give you a y-intercept. Let's say the y-intercept is at 0, 5. And let's make this point 1, 7. And we're going to draw a line through these 2 points. And we want to figure out the slope of this line. How can we do that? Well, there is an equation for that. But the first thing I'm going to do is teach you how to figure it out visually. The slope is the rise over run. Which is how many steps you have to go up and how many steps you have to go to the right. Okay, that's the basic idea for a line that has a positive slope. So let's count. To go from this point here, I can change the color. Let me try green. To go from this point here to this point, I have to go up 1, 2, over 1. In fact, to get to another point on this line, I'll also have to go up 2 over 1. And that's the slope. It's 2 over 1. So it's how many steps you go up over how many steps you go to the right. Now 2 over 1 as a simplified, 2 divided by 1 is just 2. So you can just write it in this form, a simplified form. But remember, if you see an integer, you can always think of it as the integer over 1, okay? We can also go down to over 1 to get to the next point, or down to over 1, and so on. Now, if you drew this line on a sheet of paper, you'll see that it matches up. The only problem is if you kind of made a crooked line and you didn't use like a ruler or something, it might not be so straight. Or go through those 2 points really straight. And if that happens, it might not look like visually you're going up 2 over 1. So just be careful with that. Okay, let's try another one. Before we do that, I think what I want to do is I want to show you how to find the equation. Now, you don't have to graph a line visually to figure out the slope. You just need 2 points on the line. The 2 points on this line are 1, 7, and 0, 5. The equation for slope, and this is important, is slope is y2 minus y1 over x2 minus x1. You're subtracting the y's and you're subtracting the x's. The thing is, you have to label your points. So you're going to have a point x1, y1, and a point x2, y2. So for example, this can be x1, this can be y1, and this is x2, and this is y2. So if we want to calculate the slope, it will be, well, we take y2, which is 5, and subtract 7 over this one minus this one, 0 minus 1, and you'll see you get -2 over -1. And you have to remember that a negative divided by a negative is a positive, and you get 2, exactly what we got graphing the line. So obviously, visually, if you know 2 points on the line, it's a little bit easier because you can do like a stair step kind of thing. But sometimes you'll have very strange points, and it doesn't really work to graph it. And it's easier to just use 2 points on the line to find the slope. Let's do another example. So I'm going to clear all of this. Again, pause the video if you need to write anything down. And let's do another example. So we'll plot a point, 2 points, draw the line, and then also find the equation through those 2 points. We'll find the slope of the line going through those 2 points. Let's do something different. I'm just going to draw some lines here. I'm going to do another one with positive slope. So let's go through this point here, which is 0, -2, which is also going to be the y-intercept, right? And then let's do way over here. So this is 1, 2, 3, 4, 5, 6, 7, -7. We're going to go down 2, down 4, -4. So this point is -7, -4. And then let's draw a line through those two. And we're going to figure out the slope. Now notice that this line, compared to the last line we drew, the slope is going to be smaller because this line doesn't have such a steepness to it. Okay, so let's change our color. Let's go with green again. Kind of like that green. And remember that slope is rise over run. So how many do we have to go up and how many do we have to go to the right to get to the next point? So you can go here. This is -2 and this is -4, right? So we go up 1, 2, and then we're going to have to go over 7. So the slope is up 2 over 7. That's our slope. Which 2 over 7 is a decimal. We can put it in the calculator if we want to get an idea of what that is. So let me just pull up the calculator. 2 over 7 is about 0.28, which is definitely smaller than 2, right? And you can tell because this is a flatter line. Okay, now let's verify this by using the slope formula. So I'm going to erase this so I can have some room here. So make sure you have 2 over 7 written down. I'm going to use the slope formula. M is y2 minus y1 over x2 minus x1. Now it doesn't matter which point is x1, y1 and which one's x2, y2. You just have to be consistent. And what I mean by that is when I choose my y2, I'll say this is y2, -2, and I subtract this one, I'm going to keep that same pattern. I'm going to take this one and subtract this one. But now I've got all these negatives. You have to be very careful with negatives. If you're not good with negatives, use a calculator. But what I do, -2 minus a negative. I change this sign and change that one. That's a rule that you can do. So -2 minus, so if you had something like -2 minus 5, you can make it plus minus like that. If you change this sign, you have to change the sign of the next one. Same thing here. So this is going to be 4 minus 2, which is 2, and then this is over 7. Again, you can put it in a calculator if you're unsure about the answer. But you see I got 2 over 7. All right, I'll do one more. This last one is going to have a negative slope. Okay, so let's go with another black line here. So we're going to draw our XY plane. Okay, let's make a point, let's say right here at 1, 2, 3, 4, 5. This is -5. We're going to move over to the left. I'm going to say this is 1. It's a little high, but if I make this line a little bit higher, that looks good. And then let's also go with maybe right here. This is going to be -1, comma, -2. And then draw a line through it. Something like that. Now you can see that this line is pointing downward from the left to right direction. So we know the slope is going to be negative. Let's see, how many steps do we have to go down and to the right? So if we go with the green color again, I think it was this one. We go down 1, 2, 3. So go down 3 and to the right, 1, 2, 3, 4. Okay, so the slope is 3/4, but it's negative because we had to go down. Instead of going up and to the right, we went down and to the right. Let's verify this. So we're going to use that slope formula, which says y2 minus y1 over x2 minus x1. So I'm going to just say this one is y2 minus 2 minus 1 over, then this one, -1 minus a -5. So on the top, I'm going to get -3. This becomes plus plus, and I get 4. Exactly what I got by doing it visually. Okay, great. Let's move on. Now we learned about the y-intercept, and now we're ready to build an equation of a line. The first type of equation we're going to see is the slope-intercept form of a line, which is y is equal to mx plus b, where m is the slope and b is equal to the y-intercept. So as long as you know what the y-intercept of a line is and the slope is, you can graph a line. You can also come up with the equation of the line. We'll see this in just a second. So let me give you our first example. Let's say the slope is 4 and the y-intercept, this is the slope, and this is the y-intercept. It's 0, 2. Well, we can graph that. The y-intercept is 0, 2. So 1, 2. We're going to put a dot here. And then we're going to go up 4. 1, 2, 3, 4 over 1. You can even come up with a point here, because if this was 0, 2, if we went up 4, that changes the y value to 6, because I'm going to add 4 to that. And we could just count all the way up here. And then we go over 1. So this will be 1. So 0, 2, and 1, 6. I'm actually going to graph this on desmos.com to verify this. And I'm going to show you the equation of the line. The line is going to be y is equal to, well, the slope, which is 4x plus 2. This b here is the y-intercept, takes the form 0b. Okay, let me pull up a new window. Give me just a second. And I'm going to go to desmos.com. And I'm going to share my screen right here. And I'm going to show you how to enter that into the calculator. So the equation of the line, I'm pulling this down so I can see the 4x plus 2. So I'm going to say y is equal to 4x plus 2. Now, if we look here, I'm going to zoom in a little bit. Look at that, 0, 2. We have the y-intercept, and didn't we say we had a point? Since the slope is 4, we said that we had another point on this line at 6, 1. Now the thing about their tick marks is, notice that this is half a unit right here. So this is 3, 4. So to go up 4, you have to go up like these 2 blocks here. So that's up 1, 2, 3, 4 over 1. If I click right here, I have 1, 6. Is that what I wrote? Yeah, I wrote 1, 6. We could also find another point on the line if we wanted to. We can drag this over here. We can go down 1, 2, 3, 4 over 1. We have the point -2. Try to get it just right. Yeah, there you go. -1, -2. It's interesting. Oops. This does it for you. And you can see a nice, pretty line, very straight line. Okay, let me switch back. Okay, so we got that. Let's look at some more examples. Let's graph this line, 2x plus 3. I'm going to graph it by hand, and I highly recommend that you graph these by hand before using something like Desmos. Use it to double check your work because you want to make sure you understand what's happening. So 2x plus 3, this is my y-intercept, 0, 3, and my slope is 2. So I'm going to make 1, 2, 3 right here. And then I'm going to go up 2 over 1. Up 2 over 1. I can also go down 2 over 1. Down 2 over 1. Down 2 over 1, and so on. You can find more points on that line. You can see by going down 2 over 1, I'm at the point negative 1, 1. This point is 1, 5, and so on. And if you put that into Desmos, you'll see the same points. So you can double check that. You'd enter exactly like this, and you'll see the same line. Let's try another one. Let's graph 2 over 5x minus 7. I want to mention again, just in case you're confused, that 2 is the same thing as 2 over 1. Okay, we can always divide by 1, and that's why I'm going over 1 each time. So here the slope is 2 over 5. So that's your m, which means I'm going to go up 2 and to the right 5. And then my y-intercept is 0, negative 7. So I'm going to put a little dot at 0, negative 7. And then I'm going to go up 2 over 5. Up 2 over 5. And I can go down 2 over 5. And so on. Okay, let's try one more. Let's graph this line. This time the slope is negative 1/4, and the y-intercept is negative 1. So I'm going to put a dot at 0, negative 1. And this time I just have to change one of those directions because it's negative. So it was originally up and to the right. How about I go down and to the right? Or I can go up, and instead of going to the right, I go to the left, 4 units. Okay, so 1 unit down, 4 units to the right. We can keep doing this. And then this is our line. I'll put this one in Desmos, just so we can see the same thing. So this one here. I'm going to clear this line. You can keep the lines up there if you want to and type right underneath it, y is equal to negative 1 over 4, x minus 1. It'll even show where these two lines cross. But if you put your little cursor on this blue line, you see 0, negative 1 is one of the points on the line. I'm going to clear that other line. The interesting thing about this is if you drag your cursor, you can see all kinds of points on this line. So every point that satisfies this line. For example, the point, let me go right this here, negative 2, negative 0.5. Do you see that? Negative 2, negative 0.5. That's on the line. Can we verify that? Let me switch back over. Is negative 2, negative 1/2, because a half is 0.5. Is that on the line? Well, visually, it might be hard to tell because here's 1, here's 2, and it kind of looks like it's halfway, right? It's on the line. But because the sketcher, which is me, I'm not perfect. And sometimes when I draw a straight line, it might not be perfectly accurate. The only way to know for sure is to see if it satisfies this equation. So what I'm going to do is I'm going to plug this in. So this says -2 is our x and -1/2 is our y. So is it true that -1/2, the y value, is that equal to -1/4 times the x value, which is -2 minus 1. Are these equal? So I get -1/2. I'm going to simplify this section over here. This is negative times a negative is a positive, so 2/4 minus 1. So this is -1/2 on the left. This is a positive 1/2, and if I have a half and I subtract 1, I get -1/2. If I get a true statement, then that point is on the line. Okay, great. Let's just do one more. I don't think I have another slide involved. Oh, I have this one. Yeah, okay. Let's do this one. Can we graph this line? So we have a little bit of a problem. Y is equal to mx plus b. Where's the b here? Well, you can write this as -3x plus 0 because anything plus 0 is itself, right? If you take 2 and you add 0 to it, you're just going to get 2. So adding 0 doesn't change anything. So then that's going to be our y-intercept, 0, 0. That's the origin. And the slope is -3. So it's up 3 over 1. Remember that negative tells us that the line is kind of pointing downward. And so our graph looks something like this. So the last thing I want to end on for this slope-intercept form, I'm going to give you a line, and I want you to just tell me, well, tell out loud. I probably won't hear you, but you tell me what the equation of this line is. So let's go here. Let's go here. Put these two like that. What is the equation of this line? So pause the video and write it down. Okay, so we are going through the y-intercept 0, 3. We go up 2 over 5. Hopefully I didn't do this one already, but the equation is 2 over 5x plus 3. If you're able to get that, that's great. I could put a point over here. Let me try something like that. So I'm going to draw a line, pause the video, and write the equation of that line down. So let's say here and here. Okay, so the y-intercept is 0, 5, and the slope, well, we have to go up 5, up 10, so that's 10 divided by over 5, which is 2. So the slope is 2. Y is 2x plus 5. If I did a straight line, you would be able to see that if you just go up 2 over 1, I should be going through that point. In fact, let me erase this line. Every time I could go up 2 over 1, up 2 over 1, up 2 over 1, and guess what? Up 2 over 1 right there. Up 2 over 1, up 2 over 1, and so on. And that would give me my line. Okay, I want to briefly mention another type of equation for a line. How would I figure out the line going through, let's say, this point and this point? Well, I can definitely figure out the slope, right? It's up 5 over 10. So the slope is 1/2. I have a little bit of problem with the y-intercept because the way I've drawn this, it looks like it might go through a half, but if the line's not exactly straight, I can't tell. just by looking at it. And I don't have an equation to plug in 0 for x yet. So we're going to learn how to write an equation for this type of line. And that is called the point slope form, okay? And we'll be able to find the equation of this. So point slope form is y minus y1 is m x minus x1. And what you need for point slope form is you need a point and you need the slope. Or you can have 2 points, because if you have 2 points, you can calculate the slope. So I'm going to tell you what the equation of this line is right here. We have a point. You can choose either one of these points. Maybe we'll go with this one, which is 5, 5. That's a point. And we just found the slope, right? It was up 5 over 10. So we said m was 5 over 10, which simplifies to a half. So we would say y minus the y value, which is 5, is equal to 1/2 x minus the x value, which is 5. And that's the point slope form of the line. Now you can solve for y and get it into slope-intercept form. This is far enough, but if you want to, you can say, let's distribute that 1/2. I just put that 1/2 with everything in here, and then add 5. So this is negative 2.5. And if you add 5 to it, you'll get 2.5. So the equation is y is equal to 1/2 x plus 2.5. And that tells me what the y-intercept is, which I was correct, even though I'm surprised that I drew this did so well in drawing this, because it's right in the middle here, 2.5. So 0, 2.5. So the point slope form of a line, I'm just going to write it again here. We're only going to do maybe 1, 2 examples, and then we'll move on, because this is not really necessary for you, but I think it's interesting. And if you're going to do the extra lab, you might find this helpful. So the point slope form looks like this, and you need a point, x1, y1, and you need the slope. So you can have these two or 2 points. So if they don't give you the slope, as long as you have 2 points, then you're able to calculate the slope. All right. Let's see an example. I'm going to do one with a negative slope, and I think that's all I want to do. Let's do, I don't want to go through 5 involving 5s anymore, so let me erase that. Let's see. How about right here? And this one right here. So let's find the equation of this line, and we'll verify on Desmos as an extra step. So what are my 2 points? Okay, well, -8 up 2, and then -1 up 1. Those are my 2 points. I don't have to graph this to actually figure out the equation of the line. If I just gave you these 2 points, that's enough. You don't have to graph anything, because you need to find the slope. And you can find the slope either by using the slope formula, which is 1 minus 2 over -1 minus a -8. Which is -1 over 7. And you can see that you go down 1 over, that's 3, 4, 5, 6, 7. You can graph it to figure it out. And then we have a point. It doesn't matter which one you choose, you're going to get the same thing. So y minus y1 is mx minus x1. So I'm going to go with this -1, 1 point, and we say y minus 1, because that's the y value, is equal to -1/7 x minus a -1 for this one. And I'm going to put plus plus here, because I don't like that negative. negative. So simplified, we have y minus 1 is negative 1/7 x plus 1. And then we can also put that into slope-intercept form by simplifying this. I'm going to do that up here because I'm like running out of room down here. I think I can write on the sides here, but that's okay. If I move that 1 over and distribute this negative 1/7, I get y is equal to negative 1/7 x. I distributed it here and to here, so minus 1/7 plus 1. And what you'll get is y is equal to negative 1/7 x plus 6/7, because 1 is 7/7, and if you subtract one of them, you get 6/7. Let's verify this in Desmos. So I'm going to switch over. Here we go. I'm going to write both equations. So excuse me, I'm going to move this for a second. Okay, so it was y minus 1 is equal to negative 1/7 x, and we said plus 1. Now let's see the line. Here it is. And we can see the y-intercept here, which we said was 6/7, right? Let's see, 6/7 is 0.857. Look at this, 0.857 right there. Okay, and then we have another point. You can see the x-intercept. And then the other line that we found by solving, we said that was y is equal to negative 1/7 x. And if they're the same line, if I put plus 6/7, they're going to line up. There you go. You see the purple line is now on top of the green line. So they're the same equation. Okay, let's go back to PowerPoint. So the last thing I want to talk about, I want to do some applications. So some real world applications, and these are going to be similar to some things you see on your homework. Here's the first one. I'll zoom in a little bit so you can see this graph a little bit better. This is an example of plotting points. Okay, so there's no lines, just points. And it says, what is the meaning of this ordered pair? So maybe take a minute, pause the video, and just read this graph and try to come up with what you think it means by when I say 1, 88.25. All right, so this x-axis is the number of days. This y-axis is the price. Okay, so the x value of 1 means 1 day. And the y value of 88.25 is the price. So this means on day 1, the stock was 88.25. So on day 2, it was 88.75, and on day 3, it was $89, and so on. Why would somebody want to graph something like this? So of course you could write a table, right? You could say, there's the number of the day, and here's the price. You can say on day 1, it was 88.25. On day 2, it was 88.75. The reason that we plot points is you can kind of see, if you made a line between these 2 points, you can see where it would be the steepest, right? From day 3 to day 4, you made the most money on your stock. Like your stock went up a lot compared to these days. And then over here, you can see there was a decline. So you have like a negative slope here, if you were making a line through those 2 points. The slope would be negative, which tells you your price decreased. Okay, I did mention that you can graph points in Desmos. I want to do that real quick. Just show you how to do that. And all you need to do is, if we switch back over to the graph, let me do that. Yeah. I'm going to go back here. And what I did, I think if you just, let me see. Not sure. Yeah, that's all you have to do. Let's close all of these lines. If you put parentheses 3, 1, and then another parentheses, it'll plot the point. So you want to plot the point -1, -6. I can't see it because it's a little bit down here, but now if I move my graph, you can see -1, -6. So you can zoom out and zoom in. So that's a nice little feature of Desmos. Okay, let me go back. Okay, the next thing is we're going to do an example of an application involving a phone bill. So I'm going to read this out. If you need to pause the video and read it yourself, you can do that as well. So suppose the cost of your phone bill each month is given by this equation. C is equal to 0.07, X plus 16.42, where X is the number of minutes and C is the cost. Okay, so here they gave us a graph of this equation. Okay, and it says the phone bill cost versus number of minutes of long distance. So what this is telling me, let me zoom out just a little bit. Okay, that's too much. It's telling me that X is the number of minutes. So the number of minutes I use my cell phone each month. And this Y value, or this, what they're calling C, they're using a different variable here, but it's the same idea. That's going to be how much it's going to cost me that month for the number of minutes I use. So this question says, in January, suppose you used 50 minutes for your cell phone. How much was your bill? Okay, so visually we can kind of get an idea because X is the number of minutes and here's 50. So we can just look and see where it crosses this line. And it looks like it crosses about 20. Now it's hard to tell if that's exactly true. We can try to zoom in and visually, you know, we can have like a little bit of an optical illusion here. It might look like it crossed, but it might be really close to it. So the only way to verify and know for sure is to plug in 50 in for X. So the cost is 0.07 times 50 plus 16.42. Now bring out a calculator. Take 50 times 0.07 and add 16.42 to that. And this becomes 3.5. And so you'll get 19.92, which is really close to 20. It's not exactly $20, it's a little bit less. So if you use 50 minutes with this cell phone plan, you're going to expect to be charged $19.92. Okay, let's try another one. Suppose in February you used 250 minutes. How much was your bill? Same idea here. We can look to get an idea. 250 minutes is here. This is somewhere between 30 and 40. It's almost a half, so around $35, I would expect. But I'm going to plug it into my equation, N for X. The equation's right here. Okay, so 0.07 times 250, that's 17.5. And then I'm going to add that to 16.42, and I get 33.92. Which, yeah, it's about 35, right? It's just like almost just a little bit over $1 less. And again, visually, I wasn't being very careful here. So it might be, you can see it's a little bit less than 35. Okay, my next one is in March, suppose you made 0 calls. How much was your bill? Well, 0 means X is 0. Wait a second, when X is 0, that's the y-intercept, right? So what is the y-intercept of this graph? Notice that this cost equation is written in slope-intercept form. The B is right here, 16.42. So the cost will be 16.42. That's because we have 0, 16.42 as the y-intercept. But you can also plug in 0 into that cost equation and you'll see this piece goes away and you're left with 16.42. Explain in words the equation for calculating your phone bill. So what's happening here? Notice that if you don't make any calls whatsoever, you're going to be charged 16.42. We saw that in the last problem, right? You make no calls, you're charged 16.42. That tells us that we have a flat fee. No matter if we use the phone or not, we're going to be charged 16.42. And then every minute that we use the phone, we're going to be charged 7 cents because this is the slope. The slope is the rise over run. And look, it's 0.07 divided by 1, right? So we go up. Well, y here is the cost. So we're going up 7 cents. And the x is the number of minutes for every minute. So the units for the slope are dollars per minute. And we're charged 7 cents per minute. And you can test that theory by plugging in 1. 0 minutes, you get 16.42. And if you plug in 1 here, you're going to add 7 cents. If you plug in 2, you're going to add 14 cents and so on. I have one more problem involving this. Again, if you need more time, just pause the video and go back to that question. In April, your bill was $37.42. Not how many calls, but how many minutes did you use? And what's the different about this problem? And the other problems we saw, let me go back a couple. I was telling you the number of minutes. This should be minutes here. Minutes, you see? 0 calls is 0 minutes, right? Here, I'm telling you the bill, and I'm asking you for the minutes. That means I'm trying to find X. But I know that C is 37.42. So we're taking this equation, 37.42 equals 0.07x plus 16.42, and we're solving for X. So we need to take 37.42, subtract 16.42, and we get 21. And then divide by 0.07 to get X. And we'll get 300. So 300 minutes. Let's see if that makes sense. 300 minutes is here. And this is bigger than, I think this is about half. So I would say, yeah, that makes sense, right? Somewhere between 30 and 40, and it's bigger than 35. So it does look like it's around 37.42. All right, to finish up this section, I'm going to do one more problem. It's got 3 parts, and it's from your practice problems in your homework. It says, for a recent year, children's admission to the Minnesota State Fair was $10. Ride tickets were 79 cents each. You know, if you go to the fair, you've probably seen this. To get into the fair, it costs a certain amount of money. Here it costs $10. And then if you want to go on a ride, you have to pay extra. So here they're saying the rides are 79 cents. The equation y is equal to 0.79x plus 10 represents the cost in dollars to be admitted to the fair and to purchase X ride tickets. I'll give you a second. Pause the video and see if you can answer this first problem. What is the slope of the line and what is the meaning of that slope? So the slope is the number in front of that X, because this is in slope-intercept form, and it's 0.79. The slope means that the cost increases by 79 cents per ride. Every time you get on a ride, it's going to cost 79 cents for each ride. So the units here are dollars per ride. Because you're going up 79 cents and over 1 ride. Let's try the next part. Determine the y-intercept. Oh, that's easy because this is in slope-intercept form. It's 0, 10. What does that mean? Well, it's going to cost $10 if 0 rides are purchased because X is the number of rides and X here is 0. So just to get in is $10. Finally, let's pretend that you have a child and let's say they want to go to the fair and they said, I want to ride 10 rides. Mom or dad, how much will it cost me? How much will you give me some money to go to the fair? That's the idea. And you need to figure out how much money to give your child to go to the fair. What do you need to give your child? Well, 10 rides means X is 10. So Y is 79 cents times 10 plus $10 for the admission. So this is 7.9 plus 10. You need to give your child $17.90. And that's all you need to do for this question. Okay, that completes this section. I hope you liked it, and there will be a lab very similar to this material posted on Sakai.